Okay guys, today we're going to talk about exponential growth. And I want you to understand what exponential growth actually means. So let's look at these two situations. So I've heard that seniors have 17 more days of school. Woo! Alright. So today is day one. So let's say today's day one and I'm going to give you a penny today. That's 0.01. Tomorrow I'm going to give you 2 cents. The next day that you're here, I'm going to give you 4 cents. The next day, I'm going to give you 8 cents. Okay? So I'll do this pattern, or I will do this pattern. Today, I'm going to give you $1. Tomorrow, $2. The third day, I'm going to give you $3. The fourth day, $4. So what about this pattern versus this pattern? How many people think they want to go with this? The first one. Okay? 4 people. All right, I'll give you guys a penny later. What about these people? How many people are going to go with this pattern? 1, 2, 3, 4. Bunch of people not voting. They don't get any money. All right. So we got about 5 people who say this way. Okay, this kind of growth, this is called exponential growth. Every time I'm multiplying by 2, right? So let's figure out how much money you're going to get on that 17th day. So here's what I'm going to do. It would be 0.01 times, 0.01 times 2. That would be second day, third day, fourth day, fifth day, sixth day, seventh day, 8th day, 9th day, 10th day, 11th day, 12th day, 13th day, 14th day, 15th day, 16th day, 17th day. There's how much money you're going to get on the 17th day. How much money are these people going to get on the 17th day? $17. Okay? So now, hopefully you understand that exponential growth is important. Even though, well, the total would be more than 17, but I'm saying on the 17th day, even though they get 17 plus all the rest of this, there's no way that's going to even add up to what you're going to get on the 17th day there. Okay? Exponential growth. So, what we're going to be looking at is how do these functions look when we're graphing exponential growth. Obviously, they're going to increase very, very quickly with exponential growth. So, our goal today is to be able to graph exponential and logarithmic functions with transformations. So, an exponential function is any time we have a to the x. A must be greater than 0. A cannot equal 1. Where the variable is the exponent, not the base. Key points will always be 0, 1, 1 base. Here's the reason why. If I give you any number, 2, 3, 4, whatever, so let's say that our number is 4. Well, if I plug in 0 for x, what's anything to the 0 power? 1. If I plug in 1, 4 to the first is 4. Can you see why the key points are always going to be 0, 1, and then if I plug in 1, it's just going to be equal to whatever the base is? So that's something that you should just know. The inverse of an exponential function is a logarithmic function. So if you have y equals a to the x, the inverse is x equals a to the y. Here's the reason why. Here is my original function. If I want an inverse, I turn the y into x and the x into y. If I now write this as a log, I do log, I find my base, a, I swirl it around of x equals y. So this is the inverse of that. These two are inverse functions. Our key points for inverse functions are going to be x turns into y turns into x. Same thing here. Here's my x, it now turns into a y. Here's my y, it now turns into an x. Okay? So those are our key points. So let's look at this. We just have a basic function, 2 to the x. Our key points, if I plug in 0 for x, what do we get? 2 to the 0, what is it? 1. Plug in 1 for x, 2 to the first is 2. So this function is going to have key points at 0, 1 and 1, 2. Think about plugging in a negative value. Look at this, guys. If I plug in a negative value, 2 raised to the negative 100. The calculator is not going to like that. I'm not going to do anything that big. Let's clear that. Let's do 2 raised to the negative 8th. Do you see how that is not a negative number? Here's what it is. It's 1 over 2 to the 8th. It's never going to be a negative. So if these numbers that we get can never be negatives, that means we have to have an asymptote here at y equals 0. The domain, we can use anything for x, but the range is always going to be larger than 0. The intercepts in this case, we only have one of them at 0, 1. Here's the way our exponential function is going to go. If I plugged in 2 for x, I would get 4. If I plugged in 3, I'd get 8. See how quickly it increases? But it's never going to get lower than 0. Okay? All right, over here, the key points. Well, this is an inverse, so they're just going to switch. We have the same base. These key points are 1, 0, base 1. I want you to look on the calculator at the difference between these two. Here's 2 to the x. Here is log. I need to do log base. Hold on, I have to go under math. There's log base. So I need log base 2 of x. Here's the way they look. Here's my exponential, and here's my log. And you should see that they are exact inverses. They are a reflection over the line y equals x. So my basic shape for my log, it's never going to cross here, and it's going to look like that. So the equation of this asymptote is what? Not y equals 0, but x equals 0. My domain here, if I look at where my x's start, they don't start until 0. So this domain is 0 to infinity. This range goes down as far as possible, and it keeps gradually going up. So it's going to be negative infinity to infinity. My intercepts, I only have one. Look at my intercept here, 0, 1. My intercept here, 1, 0. And that's because they're inverses of each other. All right. So now we're going to throw in the reflections. We want to do the reflections in this order for exponentials. B to the negative x is a reflection of the y-axis. It's the opposite. Putting a negative out in front is a reflection over the x-axis. If I have x plus m, that's going to be a shift. Do you guys know? It is left. It's going to go to the left m. If I have x minus m, it's going to go to the right m. If I have plus n out here, what's it going to do? Nope. Up. It does the same thing you would think when it's up or down. It does the opposite when it's left or right. This is down n. Okay, so if we had a log, it would go like this. This is with the x, okay? So this is with the x, so that's going to be a reflection in the y-axis. This is going to take it to the right m, and this is going to take it up n. For this, we're going to have a reflection in the x-axis. This is going to take us to the left m, and this is going to take us up n. Any questions about that? That should seem kind of familiar to you. You should have done this like in CP over 2 and in pre-calc. All right, so here's our big goal right here. Being able to graph any exponential and any log, whether it's a regular log or a natural log. Okay, looking here. I always like to start with my normal key points. For this function, my normal key points would be 0, 1, 1 base. But now we're going to have shifts. What kind of shift in the x direction? Left 3. And what else? Down 1. So I have to take these key points to the left 3 and down 1. To the left 3 and down 1. And now I'm going to plot them. Negative 3, 0. And negative 2, 3. Now, normally I have an asymptote at y equals 0. If I shift y equals 0 to the left 3, it doesn't change any. But if I take y equals 3 or y equals 0 down 1, it's now going to be at negative 1. So here my asymptote is going to be y equals negative 1. My domain was always negative infinity to infinity. That's not going to change. I'm sorry. My domain is now going to be negative 1 to infinity. Because oh my gosh, focus. Darn it. Let's do my video third period now. Here we go. Here's the domain and range. All right. Our intercepts. I can see this X intercept. Can you guys see the X? It's at negative 3, 0. To find the Y-intercept, I have to plug in 0 for X. If I plug in 0 for X, 0 plus 3 is 3. 4 to the third is 64. Minus 1 is 63. There's my Y-intercept. I can't graph that. So here's going to be our function. I'm even going to let you use a graphing calculator, but your goal is to graph it without. But if I wanted to check this, I can do 4 raised to the x plus 3 minus 1. Now look, guys, look how I can check these key points. I go to my table. I want to know, are these points negative 3, 0, good, and negative 2, 3. See how they're on there so I can tell that my key points are correct. All right, got to focus on this one. Key points. Normally there's 0, 1, 1 base. But now we have to look at what's happening. Do you see this negative right here? What's that going to be? A reflection over the y-axis. So if I reflect over the y-axis, that changes my x. So if I'm at 0, 1 and I reflect over the y-axis, that doesn't change this, does it? But I also have to go to the right 2, and I have to go up 3. If I have 1, 1/2 and I reflect over the y-axis, I'm going to go to negative 1, but I also had to go to the right 2, so now I'm back to positive 1. And my 1/2 is now just going to be up 3 more. So these are going to be my key points. 2, 4, and 1, 1.5, 3.5. My asymptote is normally y equals 0, but it got shifted to the right 2. That doesn't change it, but if I shift it up 3, it is going to change it. So now it's here. So y equals 3 is my asymptote. The domain doesn't change, still negative infinity to infinity. Our range is going to be from what? Correct. My intercepts, is it ever going to cross the x-axis? No, because that's an asymptote. Do I have my other one? I'll find it here in just a second. So this is going to go up like this. I would have to have a y-intercept. So I'd plug in 0 for x. 0 minus 2 is negative 2 times a negative would be a positive 2. 1/2 squared is 1/4 plus 3. So my intercept, when x is 0, I get 3 1/4. Now, guys, let me show you this. If I have y equals just 1/2 raised to the x, I want you to look at this function. 1/2 to the x. Can you see what happens with that? It's going to be what we call exponential decay. I'm going to have half as much. That'd be like right now you have $100. I take away half, you've got 50. Take away half, 25. 12.50, 6.25. I don't know the rest, but you get the idea. Will that ever go to 0? Even when you get down to a penny, if I take a half, you got a half a penny, a fourth a penny, an eighth a penny, etc. That's why this should never go down. But can anybody explain why this does not look like an exponential decay? Why does this one not look like exponential decay? It got reflected over what axis? Y. Can you see this? Look, y equals 1/2 to the negative 1. What's 1/2 to the negative 1? 2. So this really could be written as y equals 2 to the x minus 2 plus 3. See what I'm saying? So it really turned into a growth function instead of that decay function. All right, let's go down to the tougher ones, to the logs. Okay, key points for logs are normally 1, 0, base 1. But now I have to apply my shifts. I have to go to the left 1, up 2. Left 1, up 2. What are the asymptotes normally for logs? Not y equals 0, but x equals 0. But I have to shift it to the left 1. So instead of it being at x equals 0, it's going to be at x equals -1. So we got that. The domain now, the x's I can use. The first x that I come to, I have to be a little bit larger than -1. My range, I'm going to go ahead and graph the shape. This is our general shape for logs and natural logs. My range is going to be from -infinity to infinity. It just keeps gradually getting a little higher. My intercepts, I can see one of them at 0, 2. Let me show you how to find the X-intercept, which is right here. Tougher. What do I have to plug in? 0, 4, y. Y is 0. This is what I have to solve. Watch how you solve it. You're going to subtract 2 over. You're going to have -2 equals log base 3 of x plus 1. I have to change this into an exponential to solve it. Here's my base. I swirl it around. It's 3 to the -2 equals x plus 1. Have you guys done that with logs? Okay. And then 3 to the -2 is 1/9 equals x plus 1. So x is going to be 1/9 minus 1, so -8/9. There's my other intercept. Okay? And that looks about right. See how it looks like it's really close to -1. Oh, I should write that as an ordered pair. -8/9, comma 0. Sorry. Yes?
Can you move back up a little bit, please? I'm sorry.
Okay, any other questions on that log? All right, and then if we weren't sure if we did it right, I could go to y equals. I could go to math, log base 3 of x plus 1 plus 2. So here's our graph. And if you give me a graph like that, it's going to be wrong. Why? You have to know that this extends down, right? The calculators are not as smart as they should be. What happens is they're getting so close to -1 that they think they're graphing a vertical line and they can't graph a non-function. So that's what happens there. But I can see that this is still kind of my general shape there. All right, key points. Do you know the base when we have a natural log? E?
Oh, it's,
Yeah, E. It's 10 if it's regular log. If it's natural log, it's E. So my key points for these are normally 1, 0, base 1. But now I have to apply my shifts. This negative out in front, that's a reflection over what? X-axis. If I reflect over the x-axis, 1, 0 is not going to change. E1 will change. It'll go to E -1. Then what are we going to do? Go to the left 2, and I have to go down 4. And on this one, I have to go to the left 2 and down 4. Do you guys know what E is about, equal to?
2 points.
Yeah, it's another famous irrational number like pi. Pi is 3.1415926, blah, blah, blah. E is 2.71, etc. Okay, so the equation of our asymptote, it's normally x equals 0. If I shift it up, it doesn't change it. But if I shift it to the left 2, it's going to be x equals -2. I'm going to plot my key points, -1, -4. E is 2.7 minus 2 is 0.7, and then negative 5. Now, at first this seems weird because we know the general shape for natural log should go like that. But what happened to it? It got reflected over x-axis, so now it's going to go the other way. So this actually is right. It's going to go down like this because of that reflection. My domain is going to be from my asymptote on to the right. My range is going to be negative infinity to infinity. And my intercepts, let's plug in 0 for x. If I plug in 0 for x, I'm going to get negative natural log of 2 plus 4. Everybody understand that? Just plugging in 0 for x. If I plug in 0 for y, a little bit tougher to solve. Plugging in 0 for y, I'm going to bring this over here. What's our base again? E. So I'm going to swirl it around to write it exponentially. Oh, I need to get rid of this negative first. Multiply both sides by a negative. Now swirl it. So it's e to the negative 4 equals x plus 2. So it's e to the negative 4 minus 2 is what x would be. So that's going to be my x-intercept. So those intercepts are a little tougher to find, but you just need to follow the rules correctly. Okay, any questions?